Hi, welcome to Class 10 Mathematics Series again. This video's focus on probability exercise. It is designed to help students understand key concepts and prepare effectively for the exam. This video is for educational purpose only. Today's the topic cover is coin, die, and cards questioned. For any questions or concern, feel free to reach out. Let us start. Exercise 14.1 Probability. We will start with previous year question 2022 of Bosemp. The question says that if A and A bar are complementary events of each other, the values of P of A and P of bar is, what is the value? Now you have to give the answer. So what is the answer? I will give the answer at last. Just think, and let's go with 2024 question or 2017 and 2022 also. Similar question they ask. If A and B are two independent events of a random experiment, then P of A equal to what? Is it A, PA plus P of B, or P of A minus P of B, or P of A into P of B, or P of A divided by P of B? So you find out the answer. You can get the answer if you have watched the previous videos regarding the terms and definition. From there, you will find these two answer. And one more, I would like to tell you that in the previous year questions of this chapter, please find out the definition which has been already asked before. That is the previous year. Okay, let us go for next question. Okay, this question is from textbook exercise 14.1, question number 2, not question number 1. If two events A and B are such that P of A plus P of B is equal to 1, then write P of B in terms of P of A. Here, if they ask this kind of question, how you have to start writing? Look nicely. It is given that solution, since we know P of A plus P of A bar equal to 1. But what happened? What is given? P of A plus P of B equal to 1. Compare these two equations from above. We can write equation 1 and equation 2. From above equation 1 and equation 2, we have right hand side 1, 1. That means if right hand sides are equal, then left hand side also will be equal. Let us write down P of A plus P of B equal to P of A plus P of A bar. Now when we look nicely, I think we can cancel P of A and P of A because they have the same values. So P of B equal to P of A bar. So the question says that write P of B in terms of P of A bar. Because of my iPad, I cannot put that bar. So I will put here right now. P of B in terms of P of A bar. Hence the solution. So we have found the solution. Next, let us go to another question. Here, A, B, C are three events which are equally likely mutually exclusive. If you know the definition, then you will understand what does it mean. But not forming exhaustive system of event. Equally likely means 50-50 chance. Mutually exclusive means when one has already occurred, it forecloses the others to happen. Forming an exhaustive system means all the possible outcomes. Then, so that P of A equal to P of B equal to P of C is not equal to 1 by 3. This should be 1 by 3. Give one example of such situation. This is not asked in 2023, but this question is asked in 2023. So let us try to solve this question. Solution, how we can start. So let us write down that. What happened to this AB? Since what? A, B, C are three equally likely event. Then if N be the exhaustive event and let's say M be the favorable to the event A, B, C. What is given? Therefore, P of A equal to P of B equal to P of C equal to M by N. This is the favorable outcome and this is the total outcome. But we knows that, but what happened? A, B, and C are not exhaustive even. Therefore, M plus M plus M is not equal to N. Why? Because they are not exhaustive even. Then what can we say? Then we can say this value is thrice M is not equal to N. Then we have M is not equal to N by 3. Now this one, let me write like this. I will transfer this N to the other side. Then we have M by N is not equal to 1 by 3, which implies this M by N and this M by N is not equal to 1 by 3. Hence, we can prove, okay, I'll write here. Hence, P of A equal to P of B equal to P of C not equal to 1 by 3. So this is the answer. Okay, let's go to next question. Okay, nice question. Here, question number 6. When a fair coin is tossed 3 times, a coin is tossed 3 times, the possible outcome, how many outcomes can be there? Are the outcomes equally likely? So you have to give an answer. So let us see, when a fair coin is tossed 3 times, the possible outcome. Let's see the possible outcome. So solution, we can start like this. When a fair coin is tossed 3 times, the possible outcomes is let's say sample space, because sample space means totality of all the possible outcome, denoted by S equal to, let's see, 3 times. When we toss, the possible outcome is, at first we can get head, 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 then at first head, head and tail, or head, tail, head, tail, head, head, tail, tail, head, then head, tail, tail, then tail, head, tail, then tail, tail, tail. You may ask, sir, how do you get this? Okay, I'll tell you. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8. So the number of hence the numbers of outcome is 8. Is 8. Now how do you get, sir? Let's say the first toss. Here you will get head and this is the first toss. Then at second, the possible outcome is head and tail. Or you can even get, in the first toss you can get tail, and in the second toss you may get head or tail. Now this is the second toss. Let's see in the third toss. In the third toss you can get head or tail, or in this position, head, tail, head or tail. Now here also you can get head or tail. Here also you can get head and tail. So now we have head, head. Next we have head, head, tail. Now next we have head, tail, head. Next we can have head, tail, tail. So this is the way you can get. Now tail, head, head. This part. After that you can also get tail, head, tail. I think you will be able to understand. Take three at a time, then you'll get that. That is the outcome. Now they ask another question. Are the outcomes equally likely? Yes. The outcome is equally likely. Why? Because any one of the two face of the coins may come up. Because, let's say, I will write the answer. Any one of the two faces of the coin may come up. So this is the answer. In this question, sometimes you can also get some other question. Let me see. Okay, this is very important question. Let's go to question number 7. From an urn containing 4 white and 5 red balls, 2 balls are drawn at random. Find the probability that at least one is white. Okay, let us solve like this. Answer or solution. Let W1, W2, W3, W4. How many white ball? 4 white ball. And how many red ball? R1, R2, R3, R4, R5. Be the white ball and red ball respectively. Then let's find out the sample space. Sample space means total possible outcome, denoted by S. Now first let us combine W1 with all the red one. Let us combine first W1 with R1. Look how I do. W1 with R2, W1 R3, W1 R4, W1 R5. Then let's go with W2. W2 with R1, W2 with R2, W2 R3, W2 R4, W2 R5, W3 R1, W3 R2, W3 R3, W3 R4, W3 R5, W4 R1, W4 R2, W4 R3, W4 R4, W4 R5. Then let's go with W1, W2. We cannot combine the same W1 and W1. We cannot combine. Let us combine W1 and W2. When we try to take up randomly, white ball 1 may come out, then later on white ball 2 may also come out. So first white 1, then white 3 may come out. W1, W3, W1, W4. So this is the option. Suppose we get W2 first, then we cannot say W1 again because W1, W2 has been already done. So we will go for W3, then W2, W4. Then next W3, W4. I think that's all. White balls we have pick up randomly 2, 2. Now let's go for red ball. Red ball 1 is pick up, then red ball 2 can be pick up again. Or red ball 1 and then red ball 3 can be pick up. Then red ball 1 and red ball 4. Then red ball 1 and red ball 5 can be combined. Next, red ball 2 and red ball 3 can be combined. Red ball 3 and red ball 2 and red ball 4. Then red ball 2 and red ball 5. This can be combined. Then red ball 3 and red ball 4. Then red ball 3 and red ball 5. Last is red ball 4 and red ball 5 can be combined. So how many we have? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have in total, let's say, therefore, total sample space NS, let's say, equal to 36. Total sample space, we have 36. From this above sample space, what is the total combination? At least one is white. Favorable outcomes, at least one is white. Let's see. We know that the total sample space is 36. Favorable outcome, at least one is white. Let's count. At least one is white. All those which have white ball in combination. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. We have 26. So let us find out the required probability. Therefore, they ask, what is the question they ask? Find the probability at least one is white. So remember, at least one is white. For the required probability, equal to favorable outcomes divided by total outcomes. Favorable outcome is 26 divided by 36. Total outcome equal to 13 by 18. This is the answer. Okay, you can copy down. From a pack of cards. Okay, very nice question. That means playing card. Two cards are drawn at random. Remember, two cards are drawn at random. Two cards. After a thorough shuffle, find the probability that both are king. That means you have to find out that while you draw two cards, that both are king. So this kind of question in card, you have to know that there are 52 in total and there are 4 king, 4 queen. So I believe you guys know about that card. So let us write the solution. It may start like this. How many king? There are 4 king in 52 playing card. So here we have given even the total number of card and number of king. That means number one, let us find out that the probability that the first card drawn is a king. Therefore, the probability that the first card drawn is a king. That means what is the answer? Probability means favorable outcomes for the king is 4. And what is the total number of cards? 52. That means 1 by 13. Now, once we have already drawn one king at the first draw, that means there is only 3 king. Now, there are 3 king left. And what about the number of cards? 51 cards. Why 51? Because one king has been drawn. That means let's write the probability that the second card drawn is king. So what is that total number of king? 3. And what is the total number of cards? 51. Can we cut here? I think so. 3, 1, 7. So we have 1 by 17. Now we know that this experiment is an independent event. Why? Suppose we have drawn one king at first. It doesn't have any effect on the drawing of the king again in the second draw. So this become an independent event. Here remember the experiment are or is independent event. So what do you understand if there is an independent event? We know that, what do we know? P of a b, suppose a and b is an independent event, we have p of a into p of b. In the same way, this drawing of two cards is an independent event. Therefore, the required probability is equal to, the first one is 1 by 13 into 1 by 17. What is the answer? 1 by, let us multiply. Let me multiply here. 13, 17. 7, 3, 21. 2 get in hand. 7, 1 is 7, 8, 9. So 1, 3. So we have 1, 2, 2. So we have 2, 2, 1. This is the answer. So we have found out this again. Okay, that's all for today. Thank you so much for bearing with me, and please jot down all the answer. Tomorrow I will make another question. Thank you one and all.